Hey guys, today we're going to be talking about one-step equations with fractions. Now, previously we've talked about one-step equations, but they just have addition, subtraction, division, multiplication, that kind of stuff in them. You know, x plus 5 equals 7, or maybe x over 3 equals 10. Pretty straightforward stuff like that, where we can use our inverse operations to do the opposite of what's happening now and solve it and answer it to get our solution. This is a little bit more difficult though, because we have a fraction. And what's a fraction doing? Is it multiplying? Is it dividing? Is it somewhere kind of in between? Well, to be honest, it is actually a little somewhere in between. And we need to do something a little unusual to deal with it, to get rid of it. What we do is something called multiplying by the reciprocal. The reciprocal of a fraction is kind of like its version of an inverse operation. A reciprocal is this fraction, but flipped. So the numerator goes to the denominator and the denominator goes up to the numerator. So if we have 4 over 5, its reciprocal is going to be 5 over 4. And we're going to multiply both sides by that. 5 over 4. Now what occurs is on the side where our fraction started, since those are inverse operations, quote unquote, or opposites of each other, they go away. They cancel. They eliminate. They're gone. However you want to think about it, it's out of there. We're left with just x. Now usually we're able to go ahead and do that operation on the other side pretty easily. If it's like 3 plus 4, okay, well it's 7, we're done. Maybe we multiply or maybe we divide. But in this case, we actually have a whole number times a fraction, and we might need a little bit of a reminder how that goes. So here's what we want to do. We want to write the 7 as a fraction as well. If we're multiplying a fraction, then both numbers need to be fractions. Now, that might sound a little complicated, but fear not. Writing any number as a fraction is super easy. You probably already know how to do it. Here's all you got to do. You write it over 1. We're finished. That's it. That's 7 as a fraction, 7 over 1. Now that they are both fractions, we can multiply them. And in case you haven't multiplied fractions in a while, it's a lot easier than you probably remember it being. All you have to do is multiply straight across the top, so multiply the numerators, and multiply straight across the bottom. Multiply those denominators. 7 times 5 is 35. 1 times 4 is 4. We're done. That's it. That's our answer. Now there may be the problem where we have to simplify that fraction. Maybe it can reduce. It has some common terms amongst the numerator and denominator. In that case, we would do that. We want to write our answers in simplest form, but that's not always going to occur. Let's do one more example before the end of the video here. Let's say we have something like, 9 over 5. There's our fraction. 9 over 5x equals 6. Well, let's think. How would we solve that? That's all there is to it. We look at this fraction, 9 over 5. We find its reciprocal, so 5 over 9, because it's as simple as just flipping that fraction. And we multiply both sides by it. Multiply by 5 over 9 on both sides. So we can go ahead and cancel out this side here. It goes away. We're left with just x. Now on the other side, we want to write our 6 as a fraction. So I'm going to write it as 6 over 1. And then I multiply straight across the top, straight across the bottom. 6 times 5 is 30. 1 times 9 is 9. Now you're probably thinking, this can be simplified. This is one of those problems where we're not in simplest form. So let's go ahead and do that. What do 30 and 9 have in common? 3. Yeah, exactly. So we can go ahead and just kind of divide 3 out of the top and the bottom of this and get 10, because 30 divided by 3 is 10. 9 divided by 3 is 3. So there's our answer, 10 over 3. 30 over 9 is technically correct, but just not really what we would use if we were trying to be technically, mathematically where we want to be. Yeah. If you have any questions about this, feel free to drop them below. Otherwise, thanks for watching, guys. I'll see you next time.